Alright class, here's the video that I wanted to show you. It's actually an online web page that you can go to if you type in this address and follow it along. I'm going to just click play and talk to you and show you what's happening. Right now you can see little balls of light striking the photosystem 2. In this case where my mouse is, this is photosystem 2. Every time that light strikes it, you'll see something happen to the water molecules floating around here in the middle. Watch what happens. Did you notice that? I'll put it on pause next time so you can see exactly what happens. Here comes the light molecules. Here's the water molecule. It's being broken up. So the hydrogen and oxygen get broken up and the electrons get moved into photosystem 2. Also, you'll notice that the electrons are moved into a higher energy level, and that is denoted by the sparkly, flashy things. Here we go. See? There they go. And up, the electrons are moving quickly along the electron transport chain. Let's go ahead and go back to our video, go back to our book, and keep reading. Now we're on part B of the electron transport chain, the light-dependent reactions. Okay, I hope you're looking on page 211. Here we go. High-energy electrons from photosystem 2 move through the electron transport chain to photosystem 1. So they start up top and they move down. As they move down, what you're going to see happening is protons, these hydrogen ions, being pumped in to the thylakoid membrane space. You see that? How there's 1, 2, 3, 4, 5, 6 protons out here and only 3 protons out here. That's because they're being pumped in into the membrane. Let's keep reading. High energy electrons move through the electron transport chain from photosystem 2 onto photosystem 1. Energy from the electrons is used by the molecules in the electron transport chain to transport proton ions from the stroma into the inner thylakoid space. Okay, so that's exactly what we're talking about, from the stroma to the inner thylakoid space right here. Okay, so protons are being pumped in across. How? As the high energy electrons move down the chain, that energy is used to pump protons in to the thylakoid space. Just a second. So let's keep reading. Moving on to section C right here, photosystem 1. Electrons released by photosystem 2 are energized again by photosystem 1. Enzymes in the membrane use the electrons to form NADPH. NADPH is used to make sugar in the Calvin cycle. Alright, so good old NADPH is used in the Calvin cycle. Okay, so I'm going to read while you look at section C. Pigments in photosystem 1 use energy from light to re-energize the electrons. NADP+ then picks up these high energy electrons along with H+ ions at the outer surface of the thylakoid membrane, plus a proton, plus a hydrogen ion, and becomes NADPH. Let's go back to our online animation and see that in action. So here's photosystem 1. The electrons have been excited and broken off of water, and then they move on towards photosystem 2, which is over here. So this is photosystem 2. This is an electron carrier. So I'm going to click start, and you're going to see what happens. First, photons are going to hit photosystem 1, energize the electrons, and the electrons go through the carrier protein all the way here to photosystem 1. Did you notice how the electrons went up again? That is to represent energy being added to the electrons. Yeah. And then what happens? The electrons get moved over to another place. Let's go back to our book, and I'd like you to check out the picture here. See, here's photosystem 1. Here's the electron carrier. Well, that's where this is on my mouse, the electron carrier. And then here's photosystem 1 that makes it all happen again. Light comes in, electrons are energized, and NADPH is produced. Great quiz question. What happens in photosystem 2? Oh, I know what happens. Water is broken down, and electrons are energized to a higher level. What happens in photosystem 1? Oh, I know what happens. Light comes in and energizes the electrons from photosystem 2 and makes NADPH. Okay, sweet. let's continue on. Now we're going to read about section D right here. Hydrogen ion movement. The inside of the thylakoid membrane fills up with positively charged ions. This action makes the outside of the thylakoid membrane